Okay, ladies and gentlemen, I'm presenting this lecture to you as final year students who are going to graduate, well, hopefully within the next few weeks. Then you have to go to industry, and all of you started with this program because you want to become engineers. Well, different people have different interpretations of what an engineer is. And our interpretation of an engineer is that you need to become a professional engineer. Once you've graduated, you're not that yet. You're somebody who has the potential to become one. And to become one, you have to do the right things. And therefore, you have to take note of what I'm going to tell you so that you can prepare yourself very well for this process. Okay. So firstly, I would like to mention that I'm not presenting this lecture on behalf of the Engineering Council. I'm presenting it in my own personal views. I have been a member of the PIC, we call it the PIC, the Professional Advisory Committee of the Engineering Council, for about 13 years now. And I'm on the committee where people would apply, or where you are going to apply one day to become a professional engineer. Now, it doesn't mean that at that stage I'm going to be a member of that committee anymore, but I would like to give you my experience in terms of how you should prepare yourself very well, so that one day when you apply, you're ready. Okay? So the slides are available. You can go through it. Lots of it is just reading. And we do not have a lot of time to go through it in detail. So most of the slides I'm just going to skip. You can go and read it by yourself. Very simple. But here and there I'm going to emphasize very important things. So all of you, because you're graduates from this department, you can go for the category of a professional engineer. So there are different categories, and I will get to that later. And we have this, previously I have discussed this graph with you in terms of the difference between education and training. So that's training and that is education. And all of you went through a process where you were at school at least for 12 years. And most of you have been here for 5 years and longer. Okay, so you are there on the ladder. And an artisan is somebody that is being trained. You train your dog to go and fetch a ball. And you haven't been trained now. Okay, so it is different. So an artisan, you train, maybe to work on a lathe, but one day you'll put a CNC machine next to him, then he can't operate it, so he needs to be retrained. Okay, let me just put it back. Okay. So, an artisan needs to be retrained. And what happened with you is an education process. Now, although you as mechanical engineers did a program which differed a little bit from that of an electrical and a chemical engineer, the education of all of you were actually the same. Just here and there we've used different material. And because of this education process, you will forever think different than somebody who did a program in the humanities or law. Things like mathematics. Yes, obviously you are going to use it in industry. Many of you will never use it. But the advantage of mathematics was that it developed your abilities to think logically. Very, very deep systematic thinking. That was what happened to you in your brain. So your brain was sort of reprogrammed. One of the very important outcomes also was that you had the ability to do independent learning. So you'll know it's one of the ECSA outcomes that will be assessed now, or that was already assessed last semester. So if you are now here, you are not an engineer yet. You have the potential to become one if you are trained very well. Okay. And for you to be trained as a professional engineer, you're going to end up here on the graph. And that is going to take you, for most of you, at least another 5 years. You can theoretically register already after 3 years. But most of you will not be ready, and I will not encourage you to do that. Okay. So you need at least 5 years of training in the job, in the environment. And that is very, very important. Now, in this process, what actually should happen is there should be a structured training program. But there's almost no companies in South Africa that offers that anymore. 20 years ago, there were many, many good companies. All the engineers would follow a structured training program, and it would then they could register in 3 years. These years, in these times, what is going to happen is that you will have to start working on a project that needs to be done, and the training will not be the first priority, most probably, of most of your companies. Okay. It is therefore very important that you know exactly what is required in this training period. So this is definitely not 5 years that you can just go and work in industry, or 3 years, and then you can register. You need to make sure that you do the right things. And you need to take the initiative to ensure that you get the right training, which will be challenging for many of you. Most of you, when you start next year, will go on a sort of an induction. So for a few months, they're going to move you around in the company so that you can just see how things work in the company. That's not going to count at all. Okay, so you need to do the right things. Now that doesn't mean it is bad what they're doing. It is just a reality. But you need to look for the opportunities to make sure that you get 3 things. First one is basic training. You need to get basic training. The second thing is you need to design. The third thing is you need to do management. Okay. It doesn't have to be in that order. But I would really encourage you to do the basic training first, because you need at least 6 months of basic training. What is basic training? Basic training is working with your hands. So for those of you who have expectations of 1st of January starting in a tie and air conditioning office with a laptop, if that happens to you, that's not maybe the right thing. Be humble. Get to the artisans. You need to work with artisans. They're going to give you a hard time. Okay? Because many of you will have the attitude, now I'm going to train this artisan or tell him how things work. They're going to teach you how things work. Okay? You will not be even worth carrying their toolbox. So you need to win their trust and tell them, listen, please, I'm here. Help me, train me. I want to learn. At first, maybe they will allow you to hold some of their spanners or something like that, and maybe later on you'll be allowed to carry the toolbox. But maybe after 6 months, you will have some sandwiches sitting together on the toolbox. Okay. But during your basic training period, you need to work with your hands. So you need to get in a workshop. You need to do maintenance. And if we say maintenance, we end up with people that has done lots of maintenance for a few years, but they sit in minutes and they sit in meetings and they take minutes. Now that's not working with your hands. So work with your hands. Work in workshops, do maintenance, do commissioning, shutdowns, operation of plant. That is what is expected, or what ECSA requires. 6 months of it. So the sooner you do it, the better. That is my best advice that I can give to you. Because very quickly, you start getting other responsibilities, you start wearing a tie, etc., you get promotion. Going back to the workshop becomes more difficult and difficult. Okay. In the workshop and working with artisans, you're really going to learn a lot. Because there you're going to experience the effect of what engineers do. And that's a reason why you need to do that. Okay. So it is not about making you very handy working with your hands. But it's so that you can experience what happens. So the sooner you do this, ladies and gentlemen, the better. The second thing, of course, design. You need to submit a designer report of 20 pages. And all of your design reports were much longer than 20 pages last semester. Okay, and the designer report, very specifically it says, must be from first principles. At the PAC, a huge percentage of the designs, when we get them, we send them back and say, redo. Why? Because people do not read the documentation properly, and I will get to that later. And they end up almost writing essays. I don't see any calculations. So remember what we taught you with design. With design, you start with a problem, you go to the user requirements, the functional analysis, concept, the specifications, all that. You need to do that in 2 or 3 pages. And then you need to give the detail of the design. So from first principles, so your design report should be about 80–90% should be calculations, not an essay with a few calculations. Okay, don't give us a FEM or a CFD, lots, thousands of figures. You need to make it simple, but we need to see that you can do design on a more complicated level than now. That's very important. There's a very specific range statement, and I'll also show you some examples. So, again, what happens with some people is that very quickly they end up in management, and then they're in management for 5 or 10 years. Now, to do a design at that stage in your life is extremely challenging. Most people can't do it anymore because they've been away from the engineering sciences for such a long period. So my recommendation is do your basic training, get it over, and then in the next few periods, if you can do some design work, it's great. Write it up. Don't do it properly. Don't do a rush job. Some people would go to old reports and they would copy and paste from reports. We have people bringing us drawings like a wheelbarrow full of them. Okay. Now you must remember, for me sitting on the PAC, I'm not being paid for it. You know, it's my community service. And every day I do one report that I have to evaluate. So for the past 12 years, I think I've done about 2,000 of them. Okay. It takes a lot of time, you know, if you have to spend 1 hour every day on a report. So you've got 1 hour about to convince me that you should be registered as a professional engineer. If you bring me drawings like that, I just don't have the time to go through it. And most of it will not be relevant. So you need to go and condense what is really necessary and present it in a way that we can understand it. Yes, you need to make use of FEM and CFD, but that should be supplementary information. That should not be 90% of the report FEMs and CFDs and almost no calculations. It should be the other way around. From first principles, do your design. And then you can say you've done a FEM. And you can show maybe the results. But that is it. So keep it short. Also, specifications. You're not allowed to use specifications. There will be some of you that's going to end up in designing boilers. Now for that you have to use a code, an ASME code. If you do it by code, you actually just rewrite what is happening in the code. You're not designing from first principles. So in your design, you need to say that I am using codes. You need to refer to it, and you can compare your results to the code. But write us a very, very good report. 20 pages can be done from first principles, go through the design process. Okay. Right, and then with management. With management, there are 3 things that you need. You need to manage projects. Okay, money, the dollars, and people. And we need to see an increase in responsibility. So at the beginning, you're going to be at the bottom. Okay, but with time, we need to see that you are taking responsibility. We need to see that you are somebody that can put your head on the block for a big project, and you take the responsibility that it will be delivered within budget and within time. and with the resources available. Preferably with time that more engineers start reporting to you, and more artisans, more technologists and technicians. So what the other extremely important thing that goes together with this is variety. The more variety you get during this training period, the better for you. Okay. I do not encourage job hopping. Okay. But most probably this is the period in your life that it would be the best for you to do it, if you can. To move between different types of jobs. For example, people in the air conditioning industry have challenges. For them it is difficult to register. Because if you've done the first project, it's great. But with the second one, it's almost the same experience all over and over and over again. So the new experience is not really an additional. If it took you 1 year to do a project, if you're going to do another one, then you don't really have 2 years of experience. You end up with a little bit more than 1 year of experience, because in the second one you do not learn something new. Okay. So if you've ended up, for example, in the air conditioning and refrigeration industry, do one project, it's great. But then if you can move to another company where maybe there's more maintenance or there's more design work, so that you can get good involvement in that. Okay, now what is the biggest mistake that engineers do when they register, when they try to register? The biggest mistake is they do not read the documentation properly. Now I've sent you some documentation. The bad news is that by the time that you're going to register, most probably it's not going to be valid anymore, because they are moving to a web system, okay, where you're going to, on the internet, going to submit your application. But the content, the principles will be exactly the same. So please go and read it very properly. It's very important, because you know, with one of the ECSA outcomes for all of you is communication. When you apply, you will also have to give the names of 2 reviewers who's going to send in the reports. And they must give us an opinion if you are competent or not. But in the evaluation of competency, they must say something about your communication. Okay. So if they maybe say something that your communication is not that well, and we pick up that your application is incomplete, you don't read it very well, you don't submit it, it's already not a good way to start your application. So go and read it very, very carefully. Okay, these are all the different categories that you can register for. I'm not going to go into that detail. You can already register as a candidate engineer. These are the fees of, I think, 2 or 3 years ago. So I didn't even go and revise it, okay, because that's your responsibility to go and read it. So you can, at this stage already, as soon as you get your documentation from the university saying that you fulfill all the requirements, then you can go and register at ECSA as a candidate engineer. Okay. But every year you have to pay a fee. So by the time that you then register or apply for registration, you need to pay a certain fee. However, if you wait, then the fee is more. Which one is the best? Depends on you. You can go and do the calculations. It's very easy. Okay, why register? Registration has become more and more important. Firstly, it is about your peers. So the registration process is a peer review system. So if you send your application into ECSA, in many cases it can take 6 to 9 months before you're going to get an outcome. Why? Firstly, because at ECSA, most of the people there are administrative staff. They are not professional engineers working for ECSA. So what they will do is they will go through all the documentation, they will see everything is complete, they will wait for your reviewer reports, they will have to go and check your academic qualifications, if it is really you, ID, etc. So it takes a few weeks before they do that. Then they send it to us. We are about 20 people on the PAC. So then we will get your application, we work through it, we fill in a form, and then every 3 months we've got a meeting. And at the meeting, we will discuss all the feedback. Now, if everybody says, yes, you can go through, then you're going to have an interview. So then you will have an interview with 2 of the people on the committee. And only after that, then they will make a recommendation back to the committee. So it's a long process. It's a peer review process. It's people like us using our personal time to do that. And for that reason, it is not something that's going to happen in a week or 2. So you have to be patient once you've submitted. Okay. Okay. So the other things that I want to mention about why register is, firstly, as I've said, it's a peer recognition. Secondly, it's about public confidence. The public, why do you register? Well, to protect the public from you as an engineer. All of you know, I mean, if you drive over a bridge, you rely on the integrity of a professional engineer who signed it off. And as a professional engineer, you will have the responsibility to sign things off. And once you've done that, you take forever the responsibility. So even although you move to another employer, you will forever be responsible for what you've signed off. So it's a very responsible thing, a very important thing to do. Then obviously international recognition is very important. Excuse me. Marketability. If you're registered as a professional engineer, obviously you can get positions easily. But it is also on the point of becoming a statutory requirement that all designs needs to be done by professional engineers and should be signed by professional engineers. Previously, there were many companies in South Africa, especially in the defense industry, for which it wasn't a requirement. Well, it is in the process of being changed. So you'll see that many people now there in those companies also now realize they have to register, and they're in the process of doing that. For the employers, of course, you know, it's all about confidence in your abilities, etc. You can read through the slides. I'm not going to go into detail. But the forms on the website at the moment, there are 1, 2, 3, 4, 5 very important forms. 4 of them will be relevant to you, only 4. So you have to choose between mechanical engineering and aeronautical engineering. So if you go and work in the aeronautical industry, you need to look at the discipline-specific requirements for registration for an aeronautical engineer, which will be different than that of a mechanical engineer. Okay, so they are different. So you need to choose one of them. However, once you register, you're just going to register as a professional engineer. So you do not register as a professional engineer in mechanical, professional engineer aeronautical or electrical. Okay, it's just professional engineer. Washington Accord, you all know about the Washington Accord. I'm not going to say much about that, but what is very important is you cannot register or submit your application within 3 years of getting your degree. Okay, so once you've finished, then at least 3 years, that's a minimum period that you should wait. Take note that many of you who did maybe basic training, maybe you've worked in a workshop for a very, very long period, that doesn't count. Only what happened after graduation, okay, after you finished here, counts for those requirements. Okay, so, excuse me. So this is the long process that I've mentioned to you. Okay, now this is what is described as what they call acceptable engineering work. There's some policy statements about it. Take a good look at it. I will maybe get to it just now. But we sometimes end up with engineers, well, they think they are engineers, but they would start working in a company and then they work there for 5 or 10 years and they want to register. And then when they submit the application, we see, but this candidate was not doing the work of an engineer. He was maybe doing the work of somebody in between engineering and management, or maybe a technologist or a technician. It happens in many cases. And it happens very often in companies where there are very little or almost no engineers. So you have to be very careful that if you're employed somewhere as an engineer, that you're really doing the work of an engineer. In this period, what is extremely important is mentorship. Okay. So the best thing is if you start working that you're working under a professional engineer. It's not always possible. Okay, now you need to discuss these things with him. Okay, and if this mentor of yours, your line manager, is not a professional engineer, you also need to discuss this with him. Because as I've said, you need to take the responsibility that you get all the right things in place to ensure that you can register somebody as a professional engineer. So make sure that you're doing engineering work. Here you will see the essential elements of acceptable practical training. Specifically under responsibility, the work must be aimed at increasing engineering and managerial responsibility until the candidate engineers are clearly able to accept professional responsibility for taking engineering decisions. Part of the responsibility should also be to ensure that sufficient cognizance is taken of economic considerations, social circumstances, environmental factors, quality assurance, safety and legal aspects, as well as the code of professional conduct. Okay. Here he tells you what is being meant with practical training. You'll see be given progressively more responsibility until capable of accepting professional responsibility, etc., etc. Okay, please take a look at that. Now, what I've said previously, remember, when you want to register, this is not about just the number of years. What is taken into consideration is the nature of the practical training, the standard and the variety. Okay. Your knowledge of the code of conduct, there's a code of conduct. You need to know about it. You need to conduct yourself like it. You need to start doing CPD. What is CPD? It's continuous professional development. So you need to start earning CPD points. So you need to go on training courses on a regular basis and start earning these points. Recognition of advanced studies. So if you go and do a master's or something like that, then you can get 12 months off, up to 12 months. But there are also 3 different categories in which you can register. So there's the general category in which most of you can register, but then there are 2 others. The one is for the specialist and the one is for the lecturer. The specialist is somebody who has been working on the level of a master's degree for at least 5 years. So you get people who maybe after graduation would go and work in a narrow field, okay, work in a narrow field, maybe in FEM or CFD or something like that, very specialized. So if you've been doing that, not for 5 years, at the beginning you're not going to already operate on the level of a master's degree. So go and do your honors degree. It's good already for, you know, getting it up one level. But then once, maybe it takes you 2-3 years to get to a master's degree. Okay, then the clock starts. Then you need to do at least 5 years on the level of a master's degree. Then you can register under the category of a specialist, and then the basic training and the management, of course, would not be that much important. And then the last category is the one of the lecturer, in which there are other requirements. Okay, mentors, very, very important. You need the grey beards. Okay, the people with 20, 30 years of experience, you're going to show them a design and they're going to say, no, it's wrong, go and redo. Or they take the back of their cigarette box and very quickly they will tell you, no, that is the answer. Okay? Those people are the best people for your mentors. So you need to get somebody like that. In some companies, if there's not, then you can go to your voluntary organization. Your voluntary organization, you have 2 possibilities. You can go and register at the South African Institute of Mechanical Engineers or the Aeronautical Society. And in some cases, not always, you can contact them and say, listen, you know, I've got a problem where I work, there's no mentor, I need a mentor. And then in some cases, they can help you. I know of incidences where some of my students did go actually to them and there were unfortunately nobody available. Okay. So it's not to say that there will be somebody available always. Okay, now there are certain forms that needs to be filled in, forms A21 and A41. After every task and job. Okay, so if you're going to start with a project let's suppose you end up in a project where you're going to manage a project, and this thing is going to take you 12 months to finish, or 9 months. Okay, at the end of that period, fill in this form, 821. And in it, I will explain to you just now, you will have to describe what you did, okay, in the form. And what is very important is your supervisor needs to sign it. Now that is how the system works at this stage. With a web system, most probably you're going to complete it, you're going to submit it, and then it is going to, by email to your supervisor, and he needs to sign it off. That is most probably how it's going to work. Okay, so in it you're going to describe what you did. Do not go and use 100 pages, just 1 or 2 pages. You can describe a period. So do not go and fill those forms in every week like a diary. That is not what you should do. Go and do a project, finish it, and then let your supervisor sign it. So in some cases it might be small ones, maybe of 3 weeks or 4 weeks. Some cases it might be a 2-year one or a 3-year one. Okay. Okay. The basic training, I've already discussed that with you, what it is all about. Here's some more detail if you want to. Okay, you see all the red that I've put in there? Very important. This is not about being involved, because there are people who did basic training for 6 months, but for 6 months they just stand and look. And that is not the idea. The idea is, you know, do it with the people. Okay, again, please go and look at that. So the outcome of basic training is that you must be able to distinguish between safe and unsafe work practices, as well as between good and poor engineering practices. That's the purpose why you should go and do basic training. Okay, now the following are not considered valid basic training. You see, training with the aim to learn the company procedures doesn't count. Training to familiarize the trainee with the company's employed technologies, manufacturing processes, installed equipment, and the like. Most of you will have to go and do it. And it's not bad doing it, but it's not going to count for you. And that is why you need to know about it and you need to manage it. Okay, I've been going into the wrong direction. Okay, here's the design. Design is the core of mechanical engineering. You need to show evidence of adequate training through verifiable work carried out in the analysis of problems and the synthesis of solutions. Evidence is required in the form of a report, approximately 10 to 15 pages, and it must be certified by your supervisor. It should describe a sufficiently complex design to demonstrate that the applicants have had opportunity to apply their technical knowledge and engineering judgment gained through academic training. Take note, gained through academic training and practical experience in the design process at a sufficiently advanced level. Very important. The following are considered the expected outcomes. Okay, here they are, and here are some examples. Examples should be complex fluid systems, which include the rotating or reciprocating machines, such as pumps, compressors, and blowers, complex machines and equipment of major parts thereof, complex pressure systems or HVAC systems. Most of the HVAC systems in industry is not going to be on a sufficiently complex level. Okay, complex structures. And then there are examples of designs which are not on a sufficiently complex level. Pressure vessels, tanks, containers, and the like. Simple structures such as supports and the like. Common air conditioning, ventilation, or piping systems using commercial software. Stress analysis of components using commercial software without proper interpretation and recommendation. You see? Okay. What you can also do is a design review. That also counts. So if somebody did a design and you need to do a design review, that happens a lot in practice. Okay. Very important designs or complicated designs, somebody else must go and check. So a design review is also fine. And then lastly, some of you are actually going to end up in organizations where you're not going to do design at all. And then they would all come to an ECSA and say, but what now? Well, the thing is, the solving of a problem can also count as a design. You just need to go through the design process. So in any industry, there will be performances or equipment that underperforms, or there's fatigue. If you go through the whole process, using your engineering sciences to get to a solution, that also counts as a design. So take note of all this. Management is the easy part, so I'm not going to say much about it, but you'll see, for example, you need to, of course, need to know about the Occupational Health and Safety Act, etc., etc., etc. Okay, the forms, I've already mentioned that. Now, one of the very important things is in the forms. As you know, we taught you that if you write a report, it should be, what is it, third person, is that right? Third person, so you should never say, I did that and we did that, etc. Well, this is the opposite, okay? So you cannot write the report here without saying I, okay? Because we need to know what you did. Many of designs and work in industry actually happens with people. And if you write a report and say, brake system was designed, we don't know who designed it. It can be your colleague, okay? Or it can be the responsibility of your group. Okay? We need to know what you did. So you have to be very clear in saying that in this design, I was part of the group. Their responsibilities were that, but my responsibility was the following. And I did this, I did that. I designed this, I managed this. So you have to be very, very clear in terms of your contribution. Many people get that wrong. Okay. Again, it is in the documentation, but people miss it. So please, it is very important. Okay, now in this form that I've mentioned, what you should write in it, there's the detail. I know for most of you, most probably it's too small. But it is things like your responsibility, your contribution, an organogram with your position. So in the beginning, you're going to have this thing, and here you're going to be here. But with time, we want to see that you start moving up, that you start taking responsibility. The method of the problem analysis, the method arriving at the solution, the criteria, blah, 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 blah. All of it is there. Okay, so just go and take a look at it. Right, other tips. Do not attach large drawings in the design. Firstly, you know, when they get to ECSA with the photostat machine and now they have to make copies of that for 20 people, you can imagine what happens. That big drawing ends up in something like that. I can't read it. Okay, and I also don't have the time to go through a complex drawing like that. Okay. Do not include and sieve these in FEMS in color, because it's going to be photocopied and it's going to end up in a black and white that I'm going to receive. So be very meticulous in your application, professional. Read the documentation. Do not submit a rush job. Make sure that you're doing the job of an engineer and not a technician. And with the typing, when you start typing the report and also with the drawings, don't start using 8 font and 6 fonts and stuff like that. Because you can imagine these reports, sort of the last thing I do every day. And by that time, you know, I'm tired. It's late at night at home. You start becoming very difficult even to read the reports. So make it easy for the people that's going to review it. Okay. So you need to think of how can you convince us in a short report which is well prepared that you are competent, can be registered as a professional engineer. Right, so lots of this information has been summarized out of the documentation from ECSA. You can get it there. And there's an opportunity now for questions.
Okay, so can you perhaps elaborate a bit for a person that wants to follow a research path and follow academic, what the requirements are with regards to getting your registration? From my understanding, there is a different set of requirements.
Yes.
Can you elaborate a bit more?
Yes, sure. So the people that wants to follow the route of an academic, that's called the category of the lecturer. So it takes longer, not necessarily. Let me just see, there it is. So the lecturer, by doing consulting work, his research is obviously also engineering work, management, management of the workshops, management of students' projects, research projects, and all of that counts. So it normally takes, if you just follow that route 5 years. But again, there's no general rule. It depends on the detail of what you did. So for example, a student with doing his master's degree can get all the basic training if he, for example, doesn't design his own experimental setup and build it. And that's what's happening to almost all my students. So at the end of their first year as a master's, they already have done basic training. In some cases, they do management, etc. And then when they start an academic career, you do all the right things. So there are cases where many of them registered in less than 5 years. Okay. But as I've said, don't rush it. Just make sure you get everything in place, and then you can register. Okay. Any other questions? There's a question.
So I would also like to know your opinion on, let's say if you're at a company that you're, like for instance, we're looking for jobs now, but you don't always necessarily end up doing stuff that will give you professional training.
Yes. Yeah.
So if you're now in the situation where you're kind of stuck,
yes.
not fulfilling the ECSA
requirements, yeah. Okay, so the question for those of you who didn't hear it, if you now start at a company where you see things like this doesn't happen, the right things doesn't happen. Okay, that is why I'm telling you this, because it's your responsibility. It's not the responsibility of ECSA to manage you through this process. It is your responsibility. And that is why I want you to know this, okay? So it is obviously a personal decision. Many of you maybe have a bursary, you have obligations, you have to go and start working. That doesn't mean it's bad, okay? So in many cases, the experience that you're going to get is great. It might be not the right experience, but at the stage you need to make a decision, because if you want to get there, you need to know you need to manage yourself. So this combination of education and training is going to get you there. And what is now going to happen during this process is you're going to move on a career path like that. With your, obviously, as your experience increases and as you start doing more independent learning, you're going to move up here. Somebody that's going to do a master's or a PhD, they move a path like that. Because the education process is more substance, and there are other outcomes which you do not experience, and which obviously is the advantage that you have there against somebody that is being trained as an artisan. And education process is very, very important. So I would like to encourage you, for all of you, to consider doing your honors at least. Why should you do your honors? Well, 2 reasons. The one is, it is another level in terms of obviously your education. Okay. But the other thing is, it prepares you much better as a technical specialist. And the opportunities in our country previously were more in management. Okay. Now it changes to the technical specialists, because many people can manage, even people outside engineering. But the technical specialists is becoming more and more in demand. So for that reason, you know, I would really recommend to you, consider doing your honors next year. You can do it on a part-time basis. You can do 2 courses per semester. You can come in and do it in blocks. The information is on the website of the department. Do that. It is very important. Okay. So the answer is, you know, you need to take responsibility. Look around. Variety, very important. Okay. Any more questions? Nothing? Okay, ladies and gentlemen, if not, I don't know, you know, obviously, many of you will only start thinking about the registration about over 3 years from now, and then you're not going to have the information anymore, so we will try to put the video onto YouTube. It will take a few days to do that. If next year I am in a position that I can give a similar lecture, obviously I will do that. And I will do that every year. And it might be to your advantage, obviously, to look at the newest one, because as the ECSA system obviously changes, there might be some new information in the YouTube videos. But please, please, what I want to ask you is, if you think about ECSA, then that's great. But please do not firstly immediately send me an email, because that is what people do. And you know, I just cannot manage the volume of emails. The important thing is first go and read the documentation. If you've read the documentation and you want to ask me something, please, I will really send me an email and I will try to help you. But first go and read the documentation, because that's why I'm making it available to you. Okay? Another question?
There's been numerous requests about clarity on the exam times.
We'll get to the exam just now. I just want to end the video if you don't mind. Okay? So are there any other things about the ECSA? Yep.
I don't know if it's a personal question, but concerning salary,
Yes.
for an engineer, what is the least or a reasonable giving up or the least amount? Like not like most or
Okay. Okay. So the question is sort of, what is the minimum that you should go and work for next year? I'm sorry, I've got no idea. Is there somebody that can help me with typically figures? I just have an idea of about 360,000 a year approximately. I don't know if, am I in the right ballpark to start with, or is it much more by now? Most probably it's about 10 times my salary now, or something like that. I beg your pardon?
I've heard of a few guys that started working this year for about $12,000 a month.
Okay. A few people starting with 12,000 per month. I'm quite surprised. That might be after deductions, maybe, that they take home. Am I right? I see there's a
website called PayScale.
There's a website with the name of PayScale. Right? Okay.
For your qualification.
Right. Okay, so there's a website with the name of PayScale on which you can go and look. Can you tell me approximately how much it says? What does it say?
Yeah, about 225 a year.
225,000 per year approximately. You also wanted to ask something?
No, I got an email once from somebody who worked as a design engineer, which is university, and they offered about 18,000.
Approximately 18,000 per year. Okay. Are there other companies? Are there any other companies at the moment paying about 360,000 per year? Or am I too high? Not? Okay. Okay. But don't worry, it will increase exponentially very quickly. Any other questions on ECSA, ladies and gentlemen, before we end the video? Nothing. Okay, in that case, all of the best with your planning of your career. So remember, the only thing that I want you to remember today, the only thing, is take a responsibility for yourself. Go and read this documentation. If you want a good career, other people are not going to plan it for you, most probably not. You will have to plan it for yourself, and you will have to manage it for yourself. Okay, thank you very much, and with that we end the video.